everybody. So my name is Chris Torillo, and joining me today is the world famous James. If you've been playing around with the Milvus project, then you know James is the VP of Engineering at Zilliz and the key maintainer of Milvus. And James is like incredibly passionate about Milvus 2.6. So if this is the first time that you've heard him speak, you are in for a treat. And so let's just go ahead and get started. So let me turn on slideshow and just give everybody an introduction to Milvus 2.6. So, of course, you know, we are a open source vector database. Some of you might have heard, by now everyone's heard of us that's on this webinar. And we're really excited about the number of contributors and also the community engagement. So once again, I can't thank you all enough. It's really been a pleasure working with everybody. So thank you again. You know, one of the things that we like to stress to our community is that we are not trying to be everything to everybody. We are not trying to, you know, we know better that we should stay in our lane. And we really feel very strongly that where we really shine is where we focus on, which is making sure that we've built a vector database from the ground up. It's not pegged onto some other tool. It's fully open source, Apache 2 license. We know it's important because it's important to us. When we look at different projects, you guys also find it very important so you can actually look under the hood. And also we get really incredible contributions that is visible to everybody. And then thirdly, as I mentioned, we want to stay in our lane. So what we like to focus on is a fully distributed system that can really perform at scale. And we're not going to be, you know, this tool that you can just like very quickly get up and running to, you know, prototype on, although you can with, you know, Milvus if you have a little more patience. But really, we are trying to make sure that we can help your multi-tenanted, you know, very performant, very sophisticated application can really work well with vector search. That's what really focused on. So when you look at the feature set that James is going to describe for 2.6, you'll see we are continuing to stay in our lane. But there's a couple other themes that I want to make sure that we share with y'all, because I think you will appreciate that. You know, as engineers, we don't get a blank check from finance. They don't just say, go ahead, Chris, spend as much money as you want on any infrastructure. We get it. We know that we always have to make sure that we can provide a solution that's going to be as cost effective as possible. And the way that we look at it is that one way we can do that is by lowering infrastructure costs. Another is that we can build tools so that you don't have to, so we can help boost your productivity. The other thing is where we have dependencies that are kind of difficult or kind of a hassle, we want to remove them as much as possible. Once again, boosting your productivity, but it also lowers infrastructure costs and just lowers complexity overall because we know that's really important. And then also, you know, you've come to use things like object store. You already understand tiered storage. We want to make sure that whatever you have in place already, that we want to fully take advantage of. So these are kind of the themes that we have in 2.6, and it's only going to get better from, you know, after 2.6, because our goal is to make sure that we can help you make sense of all of your unstructured data. But in order to do that, we have a really big internal goal that we need to help you to reduce your costs even more. We need to make Milvus a lot cheaper to be able to use in your infrastructure. And we know that we still have a long ways to go. So we appreciate your patience as we, you know, build out these capabilities to support you. And we hope that you can appreciate this goal that we have. It might seem counterintuitive, you know, coming from a product vendor, but like I said, we know we don't get a blank check. We know you don't either. So we feel that we're kind of all in this together. All right, so I'm going to hand the mic over to James, and we'll start going really deep into what these capabilities are.
All right, nice. Yeah, thanks, Chris. I think the introduction is actually pretty good. So the goal for the Milvus 2.6 is just try to reduce the cost for everyone, so we can see more use cases. Yeah. So I'm actually pretty excited about all the new features for 2.6. We spent around like half a year. This is the first time I talk about 2.6 because I was like pretty busy about making all those great features happen, but finally it's there. Yeah. So the first part I want to talk about is how we can leverage all the cloud infras and make vector search even cheaper. Yeah. So first feature, our signature feature is actually tire storage. So you can separate all your hot and cold like data. If people like when people are making all those AI applications, one of the challenges here is like multi-tenancy. You actually build apps for million or like tens of million different users, and only small part of them is actually active users. Similar thing happens even if you build enterprise applications. You may have code data, like for the recent 3 months, it's going to be hot, and for most of the other data, so you may still want to search on it, but it's like super code, and you definitely don't want to like load all the data into memory or disk. Yeah. So that's why we built this smart cache. The architecture graph seems to be a little bit small, but just take it as another layer of caching on top of object storage. Yeah. So as we may all know that like start from 2.0, like Mil was actually using all the object storage as a persistent layer, but the original way to do that is actually loading all the data into main memory or disk and try to serving it at a faster speed, right? So we for the last couple of years, we observed a lot of people, they try to releasing all the collections managed by themselves. When people log in, they loading all their data, and when people like leave their applications, they release it. It's actually a lot of work to do, and the performance is not ideal. So we thought, why not we do it by ourselves to build another like aerial caching layer on top of all object storage, so people don't need to worry about it. So with the tire storage, you could say that the hot data performance is still similar to HNW or JSON you're actually using right now, based on either the caching is on disk or it's in memory. But if once you eviction all the data onto the object storage, you should see the latency to be higher, maybe 1 to 2 seconds. But on the other side, like for many of the other code data, like latency is not very important. But with the new tire storage implementation, you will see that your cost of storage actually dropped to like another 5 to 10 times. Yeah. So second feature I want to mention is actually RabitQ. So it's actually a quantization algorithm, which after a lot of evaluation, we thought it's actually the SATA among all the like quantization algorithm we see. So I know some of you guys maybe heard about binary quantization. So they just try to convert a 32-bit float into a 1-bit, so they can compress all the vectors 32 times, right? But the cost for binary quantization is that you lose a lot of recall. And for people who build RAG applications, you know that accuracy is actually very, very important, especially for top 3, top 5 accuracies, right? So that's why we introduced the new quantization. We'll talk about this in the next slides for a little bit details. But just remember, for any of the open source users, you got a new option, and it can be worked together with both IVF index and W index. Yeah. So third thing we introduced is int8 vector support, as well as its H&W index. We saw some model vendors, they try to do quantization by themselves. For example, Cohere, their model can generate both float 32 vectors, int8, and even binary vectors. Milvus already support binary and float 32, and now we finally support int8. So with the new int8 implementation, the recall is like 1 or 2% lower than float 32, but you get the chance to like optimize 4 times your memory. Yeah. So last thing is middle storage V2. We do fully leverage Parquet and Arrow at the very beginning of the design of Milvus 2.0. after a period, we find that the challenge is that it's very hard to store all the object storage data and all the vector data into a Parquet format. And also Parquet format has a lot of limitations on how you can do very fast point queries on object storage. That's why we redesigned our storage layer, and we'll also cover this in the next slides. Yeah. Okay. So the first thing I want to mention is the RabitQ. First of all, it's a binary quantization method. The key idea for RabitQ is that, think about this. For a three-dimensional like data, range between -1 to 1, it can be shown in, if it's a random vector, then it can be shown in any point between -1 and 1, right? But if you normalization your data with a very high dimensional space, you see that all of the data will be located in a very smaller range, very close to 0. Because when dimension gets high, then for each of the dimension, it gets some kind of certainty. It seems to be a little bit hard to understand, but if you guys are interested, you can just go to read the paper. It's actually one of the best paper on Sigma 2024, and you by leverage these features, it's actually some kind of stats. So we can actually reduce the link to the paper. Yeah, we'll show that later. Yeah, you can actually reduce the average error between your quantized vector and your original vectors. Yeah, so using RabitQ, you see high search accuracy, and the other best part for this is it's fully hardware friendly, so you can optimize it with SIMD instructions, and it can be combined with any kind of index, especially for fast scan. They have the other paper talks about how RabitQ can be worked together with the fast scan for better performance. So we'll definitely share all those two papers. Yeah, but from our like result, if just to think about one bit without any refine or without any re-ranking, it seems to be 3 or 4% higher on the accuracy compared to the traditional product quantization, and the performance is 10 times. Yeah, if you compare with scalar quantization, could be even like 10% like higher, recall higher, and also the QPS is kind of like similar with the scalar quantizations. So leverage the new quantization algorithm. We actually implement IVF RabitQ, and also the and also the HNW RabitQ features. So using this, it's actually under the same recall is actually double the QPS, and it also can save you some memory compared to the our original IVF index. Yeah. Next.
So you just have a little question about high accuracy.
Okay. So how do we define hierarchy? That's a good question. So usually we use two things to evaluate accuracy. One is recall, which is saying if people are asking for top 100 result, how many results is actually get retrieved after doing a nearest neighbor search. So if you're using brute force search, then your recall is definitely 100% accurate. You get all the 100 results. But using any kind of nearest neighbor algorithm, you should see you might missing some of the results. So ideally, we want to see like 98-99% of your recall. But once you do heavy, like if you're using HW index or discount index, you can definitely get 90, 98, 99. But if you're using some index like IVF index, you might get 95. And if you do quantization, you should see your recall keep getting lower. And for example, the naive binary quantization, you should see recall under 75 or 80%. So which means if you search for top key 100, you get like 75, 80 of them. Yeah. So the other one is using NDCG. So the major difference between NDCG and the recall is that it's not only evaluate how many results it can get, it also evaluates its ranking. So the higher the ranking, for example, the first result has the most weight, is most weighted. So if you get the first if it should be the closest one, but it actually shows in your search result to be the like 20th, it's still good because you get the result, but it's not ideal, right? You want the search result to be shown on the first position as well. So that is in DCD. It considers all the recall, but also the ranking. Yeah. Okay. Yeah. So the second exciting feature is actually storage v2. So it's actually working together with the Terra storage because originally what we do is just loading all the data from object storage and caching it. So we don't really care about the performance of our storage format. Yeah, but in the new release with the Terra storage and with the next release when we have the vector lake solution, so the storage on the object storage becomes very, very important. Many of you might heard about the lens format, which is actually designed for vector lake. We kind of like implement the same thing, but using fully Parquet files. So it actually compatible with all your stacks. So you don't really need to introduce a new format into your big data or into your like AI inference. Yeah. So the goal for Start V2 is actually two things. One is that we want to introduce more data types, especially unstructured data, for example, long tags, for example, the blob storage, which can help you to store all the images and audios into a vector database. So those data is actually going to be huge. So you cannot directly store those data into Parquet because it actually breaking your row group. Think about this: you have one field with 4 bytes in each row, and the other like field with 4 kilobytes. Then what could happen is because Parquet is trying to store all the data into same row group, right? So then what happens is if you tune the row group set to be really, really large, then you have huge amount of data on the smaller fields. Yeah. And if you want to retrieve one of the fields, it's going to be very expensive because I have to retrieve the whole row group. But on the other side, if I tune the row group to be smaller, then for the large field, they may only have like 10 or like 20 rows in one row group. And then the filtering speed or the sequential read speed could be low. So it's kind of like a dilemma. Yeah. So the way we handle that is actually we split large and smaller field into different row groups or different files. Yeah. And we put all the vectors stored outside of Parquet because the initial version, the start V1 version, we actually store all the vectors in a Parquet array, and we found that the deserialization is actually very costly. So that's why we also move the vector out of the Parquet. It's not designed for vector at all. Yeah, we also fully leverage the Parquet page stats to accelerate punt queries. So it seemed to be pretty stable, battle tested. And from our tests, we see that compared to Start V2 and V1, we actually get 50 times acceleration on punt queries. So that is very impressive on the Terra storage use case. Yeah. Next slide. Okay. So we care not only about cost for sure. Yeah. During the last couple of years, we've been working with AI developers, try to build something they can like all the tools so they can easily depends on. For example, the hybrid search features. At the very beginning, we thought you should just use two systems like using Elastic and Milvus. So you can manage both and do a hybrid search using your own logic. And people complain a lot about it should be simplified. There's no need to maintain two different clusters. That's why in the last Milvus release, we actually support hybrid search and also full text search, right? So similar things happens here as well. So one of the most exciting feature we want to talk about is data in, data out. Yeah. So a lot of people is keeping asking us why cannot just vector database working together with my embedding models, so I don't really need to call the API twice. So usually what's going on here is people call OpenAI and probably call Gemini embeddings, get the embedding and try to concate their scalar fields with their embeddings and ingest into Milvus. Yeah. So but it's not only about embeddings. There are a lot of pre-processing. Sometimes you also need post-processing. For example, you need re-ranking, you need highlighting all your data. And we thought we need to integrate this, but we also need to offer some kind of flexibility to our users so they can design their own pipeline to processing their data. So in the 2.6, we actually introduced another functionality which we call it a pre-processing pipeline, post-processing pipeline. So using pre-processing pipeline, the easiest usage is you can directly call all the embedding vendors using Milvus, or we can even work together with inference engines such as WLM or Hugging Face text inference engines. So you don't really need to host on that. And also on the open source Milvus 2.6, our Kubernetes operator already supports to bring up a WLM inference engine. So we actually not helping to call those embedding model inference, but we also helping to deploy those inference engines. But you can also like use, for example, OpenAI or Cohere, so you don't really need to like manage all those stuffs. Yeah. Post-processing is actually doing the same thing. The initial step is we implemented a re-ranking model, so you can call in Cohere or calling Google APIs to just get a re-ranking. But in the next couple of release, we'll also support more complicated pipelines. For example, highlighting. I know a lot of people when they do search, they want to show their customers and explain why certain results is actually picked from the search, right? So that's why we're working on highlighting. The one of the differences between our highlighting and like traditional search engine is we do semantic highlighting. So it not only shows the keywords, but it also shows the semantic relations. Sometimes you can if you're using dense embedding search, you can actually get a result without even any of the keywords, but it's still semantically related. So using our latest highlighting, this is not there yet, but should be come out in the next 1 or 2 months. So using the semantic highlighting, it's easier for all the React developers to explain why this is actually searched. Yeah. So we also implement the data model. So the struct list or embedding list is it's something really cool, and I'll explain this in the next slide. We do improve a lot of search functionalities, phrase match, helping you to match a phrase. So 2.5 we already support keyword match, so you can match a couple of keywords, but phrase match is actually helping you to match a keyword, a phrase, for example, vector database instead of match vector and database. And you can also care about their locations, so you just search vector and database, but not database vector. Yeah. We do have a multi-language tokenizer. One of the tokenizer we introduced is Lindera, which is pretty good for Korean and also Japanese. And the best thing for that is we also wrap a multi-language tokenizer, because as we see, as the word becomes more global, when people build applications, especially AI applications, you are actually a day one global application. You serve people from multiple parts of the world, not only US, not only Europe. Yeah. So using the multi-language tokenizer, we actually be able to support more than 60 different language. And as long as you can specify which language user are using, then we actually split the BM25 for different tokenized like language into different stats. So you don't really need to worry about like different language users that actually have some influence on each other when we create these stats. Yeah. So we also create a bunch of like interesting tools for developers to make their development moves faster. One of the cool feature we add is add field, because right now the schema for Milvus is actually pretty stable. So if you said I have 3 different field, one is ID field, the other one is a vector field, maybe the other one is your text field. And someday you said I might need to add some tags or some features on another field, but there's no way you can backfill all the data and add another field. So you have to copy all the data, doing all the ATLs, which is very expensive, especially if you have large amount of data. So right now you have the option to add another field without break the traffic. Yeah, we have a create sampling feature. So sometimes you just need to have a taste of what's actually in your collection or in your data, but you cannot just scaling on that. Right now, we actually offer a query sampling feature, so you can sampling some of the data in your data set. And using this query sampling feature, you can also search and evaluate your recall. So that is also a new feature offered on this cloud. So because a lot of people, they don't have a ground truth, they don't have a real world data set to evaluate how well their search or their accuracy is. But using the clean sampling data plus the recall estimation, you'll be easily able to understand how well your query actually does in production environment. Yeah. So time-aware decay function is a re-ranking algorithm working for agent builders, because we know that agent memory sometimes we want to prioritize fresh data instead of like old data. That is similar as a human, because we forget a lot of old things, right? So in the newest 2.6, we actually introduced this decay function. So we have multiple different kind of decays, but the general idea is the newest the data, the higher relevancy or the higher priority it will have and show on your search result. Yeah. So last is an improvement of time to live feature. We actually introduced time to live long time ago, like 2-3 years ago. But there are some major limitations. We keep heard from users that even if time is actually already expired, it's actually not actively cleaned, and it's can still show in the search result. So in the newest 2.6, we actually improved the TTL feature. So for all the data is actually expired, it would directly removed from your search result. And we also have a limitation like a deadline compaction strategy. So for any data which is expired for more than 1 day, we just do compaction and clean all the data. So you have a guarantee to clean all your data. Yep. Okay. So one of the cool features for 2.6 is for reg users is struct list. Yeah, because originally we have this table model, and each of the primary key is unique. So when you build reg applications, especially for like talking with your PDFs or web page, what you always do is for each of the row or each of the entity inside Milvus, it's actually one chunk. It's not one document, right? So the problem for this is sometimes when we do search, we want to search the most like top 10 similar documents instead of similar chunk. That's why we introduced a feature called group by in 2.4, and so you can search and group by with document ID equals to something. So just to show you top 10 most relevant documents instead of chunk. But we saw this is not really good enough. Couple of reasons for that. First of all, sometimes when we do search, we want all chunks inside each document to be co-located together, so we can do some extra either it's re-ranking or some extra computation on top of it. One of the best example is to using multi-vector or cobert embedding models. So if you're using cobert for each of the document, they are just generate multiple embeddings, and when you do search, you actually need to do a maximum distance. So when you do maximum, you want to make sure that all the vectors inside one document is actually co-located together. Yeah. So that's why we introduced a new data model. You still have a primary key, and the primary key is the document ID. And inside each row, you can have a list of embeddings. So if you do chunking, let's say if you split the document into 10 chunks, you just put the 10 chunks into one tensor or into one list of embeddings instead of putting into 10 rows. And based on that, you can do a lot of re-ranking implementations. You can, or we also see a use case where people want to do time series on their vector embeddings. That is a video use case, right? You actually do cutting all the videos into frames, and for each of the frames, they actually have context informations, and they have time series relations. So we actually introduced a special metrics. So the embedding distance calculation can actually taking care of the time series relations. Yeah, and the best part is not only about embedding this; it's also a struct list. So which means you can design a schema which you have a title embeddings. You have some tags in the titles, but for your content, you have a new struct. The content is actually split into like 50 different chunks, and for each of the chunks, you can also have some other metadata field, and then you can filter on the metadata field as well. So the data model itself becomes more and more complicated, and it's actually we're just trying to catering all the need for the React developers, and that's why we believe why this vector database need to be there. If you want to add the similar thing in a PG vector or Elastic, it's very hard. And the way we do that is actually we start from the index itself, and then try to modify the Milvus, the database layer, pretty much similar to what they do on Elastic in the last 10 years. Many of the innovations happen on the Lucene side. You need to know a lot of details about your search engine. Then on the top layer, you build Elastic, trying to leverage all those features into a more scalable way. Yeah. So there's a question, how does this compare to OpenSearch and pgvector? I think I will compare it in 3 ways. First, if you have 1 million data and you're just doing naive regs, please use pgvector because this is the easiest way you can do vector search. It's not good at performance, not good at skill. We are good at it, but it's kind of like based on your use case. So second difference I would say is that we did a lot of optimization on the how we can work with AI applications, for example, the hybrid search, for example, the new data models. So it's easier for all the developers to fit in their applications into the new data model. Yeah, just like MongoDB, when you do like mobile applications, at the very beginning, nobody wants to store their data in a relational database. They just want to store their JSON in a super easy like document stores. Similar things happens here. When you have vectors, you might have different kinds of vectors, not only like very simple dense embeddings. You also have sparse embeddings, have vector lists, multi-vectors, binary vectors, and you want to find a database that can easily store everything into it. Yeah. Next page.
Something, hang on, stuck here. Stop. Sorry about that.
Yeah, so maybe a couple of more comments on the OpenSearch. So today we do release our Vector DB Bench 1.0. So yeah, it's actually listed here. So it compared Milvus Zilliz with many of our the competitors or the players in the market. It's for sure it's open source. So feel free to evaluate by yourself. So the interesting part is it kind of like become a standard because every other vendors who want to support vector search actually contribute to Vector DB Bench and for their own connectors. So it's also a lot of fun for us to providing different kind of systems and see how it does. Yeah. So I think third part I would say is performance. Yeah. As you may know, Milvus is actually known for its scalability and performance for quite a while. We do have a couple of large customers, probably the largest customers in the planet. Yeah. One of the most exciting feature, I would say this is probably the most exciting feature I see in 2.6 is JSON shredding and JSON index. So in 2.2, we actually introduced a dynamic field. So it makes your data model more flexible, but on the other side, it makes your filtering super slow. That's how we see in the last 1 year. Yeah. So after a lot of evaluation, we actually leverage the JSON shredding policy. So it's kind of like very similar to what ClickHouse does. We'll explain a little bit about what is JSON shredding, but the results seem to be very, very impressive. We see 100 times performance improvement on like dynamic filterings. So which means after 2.6 rolls out, you probably don't really need to think about your schema as serious as before 2.6, because even if you make mistakes, don't worry about this. You can still using dynamic schemas because the filtering speed is almost similar compared to the like a fixed schema data. So that could be a big difference. N-gram index is actually using for regular expressions and like. We know that Mil is not built for that, but when a lot of reg use cases, we still see people trying to using text match or like to match some of their keywords. So we build this N-gram index. So so the design, like we split all the data into smaller tokens. For example, if you do 2 gram, then we split all your data into a group of 2, and we build an index on the each 2 characters. And when search happens, we just, for example, you search for hello, then we just split hello into group of 2. So you search for it, whether HE is in your text, whether EL is in your tag, whether LL is in your tag, and LO is in your tag. If all of those 2 gram is in your text, then which means this text is actually a match. So you can do 2 grams, 3 gram, or even like 4 gram. So the larger the granularity, the less the resources. But it also has some limitations, because if you do 4 gram, then you cannot search for like token with three characters. Yeah. So this helps to accelerate all the text match and regular expressions. So mean hash is a locality sensitive hash index built for huge amount of data deduplications. We're working with one of the world's largest large model training companies. So they have 10 billion level data crawled from all the web page, and the first thing after they crawl all the data out is they want to do a deduplication. So we actually create this algorithm which called mean hash and build an index on top of it. So it can help people to do large scale deduplications. Currently, the production environment we run is actually about 10 billion vectors. And there's a lot of optimization to do. For anyone who has that large amount of data, we're definitely happy to help. So come to us, and maybe not this use case, but we would definitely glad to help on like optimize on it. Yeah. So async PyMilsCon is a lot of people asking for that. So it has well implemented and also integrated with Llama Index and Longchain. So for anyone who is interested in using async, feel free to give us a feedback. Yeah. So last thing is the VDB bench. So I already talked about this. So just go to GitHub and search for vector database bench. The first one should be VDB bench under this tag. Just try it, and we get a fancy UI, so you can see all the results, and it's very easy to deploy just with one single Docker. Yeah. So just give a very general idea of what is JSON shredding. So on the left side is a JSON field we have. We have a couple of different paths. One is A, the other one is B. So the special part for B is that not all the data in B is actually under the same data type. Some of them are strings. The other ones are actually integers. And we also have D, E, and F. So they probably just show in some of your entities, definitely not all your rows, right? So we actually split all the data into three different type of case. If A is shows in all of your data or most of your data, then we call it as a tapped case. So we directly store it in one columnar storage. For B, and for example, they have both strings and integers. We actually split into two different columns to store them. One of them is a string column, and other one is a int column. And for the columns which don't have this data, it's just using null. Yeah. So similar thing happens on D, and you have all the strings. And for other like entities which don't have this field, you can just fill in with null. And for the rest of your data, then you can store it with a BSON format, and we actually create a BSON stats on top of the format. So it's kind of like an inverted index. So search on it should be much faster because all the data only shows in part of your JSON or part of your entities. So by creating an inverted index, it actually accelerates the filtering speed. So with all that data, we actually seeing accelerating between 10 times to 300 times, and dynamic filtering seems to be always done in less than 10 milliseconds. Yep. Okay. So last part we want to mention is how to reduce the maintenance costs. We all know that Milvus is actually powerful. It's scale, but on the other side, many people complain about it. It's actually hard to maintain, hard to get started. We know that's why we build a lot of helpers. We do have a Milvus Lite, which is a embedded version. So people could just install it using a pipe install and running it on your laptop. We do offer different kind of deployment. I think as an open source product, we are kind of like very generous to offer all kinds of, like, for example, the Kubernetes operator. Even you can do Helm, you can do Docker install. So in the 2.6, we also have support apt and yum install. So it makes people life even easier. If you just want a single machine solution, you don't really need to install Docker anymore. Yeah, and beside that, for any of the distributed user, one of the key argument is that people saying that Milvus is very heavy because you introduced Kafka or Pulsar as a Red Hat logging. The reason we do that is by that time, like 4 or 5 years ago, we decided to do compute and storage desegregation. But and on the other side, we also want to make sure that this database is good for your data freshness. It's definitely not a batch database. It has to be handle all the CRUDs in real time. That's why we pick Kafka and Pulsar as our Red Hat logging. So after so many years, we see great improvement on the storage layers. S3 becomes even cheaper and much faster. And you also have the single AZ S3 solution. So the latency is actually 10 times faster than the standard version. So we thought it's the right timing. We just introduced another layer to replace Kafka and Pulsar. Yeah. We also did a bunch of optimize on reduce the component number. For example, we merge index node and data node into one node. We also merge all the coordinators, root query and data coordinators into one mixed core. So we don't really need that much microservice. So people may fear about this. Yeah. Next bit. Okay. One of the most exciting features in the architecture side is the stream node. Because I think a lot of people, if you get a chance to use Milvus, you know that we do have a tunable consistency model, so people can pick between strong consistency to bounded staleness or even eventual consistency. The reason we do that is that strong consistency implementation is slow in any version before 2.6, because when write happens, every write directly goes into Kafka, and it can be only consumed or can be searched when query node actually consumes the data. So it may take some time for Kafka to deliver all the data to the consumers, and it also takes some time for us to notify the query node whether you have the latest data or not. right? So that's why we decided to do a major architecture change. We're actually adding a new node called stream node. It's actually, you can think it as a replacement for data node. So all its fresh insert is actually inserted into the stream node. And using the stream node is actually responsible for writing the wall. The wall can be either a Kafka or it can be a Woodpecker. We'll talk about this later, right? So after the data is persisted in the WL, then stream node actually apply all the data into its memory. So all the growing segments is actually moved from query node to stream node. Yeah. So by doing that, the strong consistent search becomes much faster, and also we will introduce some interesting feature. For example, primary key deduplication. For example, indented write, because the other complaint about many of the users is that when I try to write data into Milvus, and if it reported error, I don't know whether I should retry or not. If I don't retry, I might lost the data. But if I retry, I may have duplicate data in my database. So it's kind of like dilemma. But right now, using the stream node, we'll just gonna have an indemnity cache. So this is also part of our feature plan for 3.0. So if you retry, you definitely see that there will be only one like entry left, as long as the indemnity ID is the same. So using the stream node actually solved a lot of previous challenge. So other exciting one is the Woodpecker. So it's a diskless, purely cognitive Red Hat login service on S3, and of course it's open source on the ZTech repo. We actually read an engineering blog. Actually, I actually read an engineering blog on the talking about why we need the new Woodpecker solution. But I think for many of our users, it's just like you can remove your Kafka dependency if you are not very sensitive to the write latency. Because right now we're just trying to write to object storage. The latency is actually going to higher. So you should see typically 200 to 300 millisecond write latency if you're using Woodpecker. But under a lot of AI applications, I don't think it's a big deal, especially if you do batching. But the good part is the throughput is actually much larger compared to Pulsar. And also it's you actually remove one dependency, so it can actually save you a lot of costs, especially under smaller clusters. Yeah. Okay. So I guess that's pretty much for 3.0. So sorry, 2.6. I'm so exciting that 3.0 is actually in the plan, probably going to happen in the next 2 or 3 months. So stay tuned. We do have this vector lake, which is a big thing. That's why we actually have this special 3.0 version. Yeah, but before we wrap up, maybe we can quickly go through one use case, which is Read AI. We are very exciting to see them actually using Milvus as a backbone to do their semantic search and try to solve the problems of your interpret data silo. So you have a lot of meeting nodes, you have chats, you have emails, you have a lot of information in your CRMs. It's very hard to like pull all the data together and help you to understand your business. So our friend Read AI, they're trying to build an agent among all those data. And of course, vector search is actually one of the important components in their solution. So they start from fast, but it's actually lack of the multi-tenancy support. We tried several different solutions, including Pinecone, and they cannot handle all the filterings, and all the cost is also a big problem. Latency is much slower. So that's why they come to us. After using Milvus, we see like 5 times speed up. And especially on their multi-tenancy use case, they'll be able to support more tenants. And the migrate is actually very smooth. And I don't think they even spend too much time on migrating all the data. So if you have the same trouble on filtering, on the how to handle multi-tenancy, you should definitely think about this. And it also help them to reduce the cost by using the DC index. Yep. I think that's pretty much what we want to share.
You have some questions.
Questions indicate OpenSearch and pgvector might not be good with performance and scale. Is that for certain use case? I would say it's in general. First of all, pgvector I think is still a single machine solution. So and what they're trying to do is actually build a huge index on top of all your data. So you have 1 million, 2 million data that is good, but have 10 million data. First of all, building the index itself is going to be very, very expensive. And also, there's no way to scale. Like 10 million might be work, but after that, it's definitely not going to be work. And as far as I know, pgvector store most of the data in memory. So like if you have huge amount of data, that will also be a big challenge. For OpenSearch, first of all, they can scale a little bit. The good part is hybrid search. This feature is pretty strong, and if you do RAG and you prefer to do full text search, I would say OpenSearch is still a very good solution. Challenge here is first of all, OpenSearch is written in Java, so they can not fully utilize all the SIMD instructions to fully utilize your hardware resource, and also the memory management for OpenSearch is really bad. So most of the users can only use like 40-50% of their memories in production environment. But if you're using Milvus, you can at least using 70-80. Yeah. And also index building for both pgvector and OpenSearch, one of their challenges is to try to build index and serving queries in the same node. So what could happen is if you ingest all the data, you will see your performance quickly drop because index building takes a lot of CPUs and it actually slow down your queries. Yeah. Deduplication has been around a long time at the storage level. How will this be add more value? Okay, so our deduplication is not simple block level deduplications where we're just trying to search for hash value and compare between like whether two texts has exactly the same. So what we do is actually a similarity deduplication. So even for many of the materials on the web page or on the internet, they might be almost the same. Like 99% of them are the same, but they just change, for example, the author's name, or for example, they just have some kind of like special slogans or logos. So it's pretty much similar, but it's not ideally the exact same, right? So the easiest way to do deduplication is just to calculate the hash value and compare. But in that way, it's like just like the keyword search. It's they don't understand the semantic. But using our main hash, you can actually find the most similar document because for training models, you don't really need to keep giving them the same materials, and you want your data to be really, really high quality. That's why they use vector database to do that. Yeah.
If you have any other questions, we'll stay on the line for a few minutes.
Yeah. So feel free to see our release blog, which is written by Chris, and it's pretty fancy. You should see a lot of details, and we're going to have our release note today, and yeah, there are a lot of information. We do build a AI bot on both the open source Milvus and our fully managed Milvus this cloud. So if you have any further questions about 2.6 or about general Milvus, go to the website, talk to the bot. If it's not working, there is actually a contact us button, so you can directly contact us.
Cool. So if there's no more questions, then we'll end the webinar here. Clean up the video, fix the audio. Sorry about that. We got a couple of new mics here. And then, yeah, if you want to chat with James, just sign up for one of the office hours, and he'll be happy to go into a lot more details with you one-on-one, or one of the other engineers can as well. So thanks everybody for joining us today, and can't wait to hear what you build with Milvus. Bye.
See you.